Today we discuss about intermediate code generation. So we have seen that in compiler there are multiple phases: analysis phase and synthesis phase. In the analysis phase we have lexical analysis, syntax analysis, and semantic analysis. Once semantic analysis is successfully over, compiler will generate an intermediate code for the source code, and this intermediate code is used for later phases of compilation. Out of this, we have discussed in brief about all the phases, in some detail about lexical and syntax analysis phases. And in the intermediate code generation, we have this many topics to be covered, and we will discuss about the need for intermediate code generation, what is meant by intermediate code, and an overview of different kinds of intermediate codes. Then we will see how the actual source code is to be translated, and we have few case studies upon this. So in between, we will touch up on topics like type checking rules and syntax directed definitions. So let us discuss about intermediate code representation as such. So we know about this analysis synthesis model of a compiler, wherein the front end analyzes the source program, and after the analysis part, what are the parts, what are all the aspects that are getting analyzed, whether the source program is as per the lexical configuration of the input language. Then the syntactical correctness of the entire statements of the programs will be verified. After that, semantic aspects of the programming statements will be evaluated. And we know that in the lexical phase itself, a special data structure called as symbol table will be created, and the symbol table will be continuously updated during all these three phases: lexical phase, syntax phase, and semantic phase. After this, directly the compiler designers could have went for the target code. But in between, they made a decision that an intermediate representation will be created. Now, what is the need for that? That's a basic question we have to answer now. Why an intermediate code is necessary? Why can't the compiler generate the actual machine code as soon as a source code is clearly verified for its lexical, syntactical, and semantic correctness? And what will happen otherwise? So the question is that we know that every software unit is created out of several iterations and trials and errors. The compiler in what we see in our form was not built with one day. There were a lot of works went on to this concept, and we have seen that a compiler is a byproduct of many related technologies, including machine architecture and organization. So the growth of compiler, both the hardware and software aspects of the computer system, has a direct impact on the compiler technology. Hence, we will just see. So we can say that even without an intermediate form, translation can be done. See here, this is a kind of translation. We are translating the source code into intermediate code. Then the intermediate code is fed to the backend part of the backend part. What is in the backend part? In backend part, in the synthesis phase, there are only two phases. One is code optimization, and the other is code generation. So why it is required? So this is a question that might be asked, and that is already asked in several question papers. Explain the need for intermediate code. And this will come in section unit 1 of our question paper. See, there could be instances where our machine code will have to be run on multiple machines. Just take the example of a mobile app. Mobile device will be of different architectures. We know that every mobile device will not come with a single CPU. So depending upon the type of CPU, the machine code will differ from machine to machine. Suppose that we write an application and that application has to run on multiple machines. So what we will do? Suppose that we don't have an intermediate core representation and we have different kinds of machine architectures. So the compiler will have to, or the person who compiled that machine and produced the target code for final product, he will have to generate, depend upon compilation for multiple machine architectures. So first the source code will have to be translated to generate, say the code for an Intel machine. Then the same thing could have been happened, translated for say an Apple machine. Remember all the entire phase of compilation, starting from lexical to code optimization. Suppose that we have an intermediate code, then we can see that right from lexical analysis to semantic analysis, the process will be similar. Whatever might be the machine architecture, we can take the source code as such, it will be in the high level format. We can apply lexical analysis, we can apply syntax analysis and semantic analysis, and we can generate intermediate code. Then the intermediate code can be fed to machine specific modules. Suppose that we want to create a, say, the whole source code, say, for an ARM machine, then we can use the backend code machine specific codes. So we can save the developers community, they can save a lot of time because of the presence of an intermediate code. And that's what it is discussed in these 2 points. When the same program is to be translated to multiple machine architectures, then the entire analysis phase can be made as a common thing. Then machine specific translation can be done. Similarly, when several high-level languages need to be compiled, only the translation to the intermediate code is to be written for each language. Other part can be a common thing. So this is the main easiness of an intermediate code. Other thing is that we know about a code optimization phase in compilation. And in our UG days, at least we might have heard about that. In our unit first, we have discussed about code optimization. What we do in code optimization? The source code written by the programmer will be modified for better output. Now, to apply this modification, or called as code optimization, people have found out that intermediate code representation is very a handy tool to do these modifications. So whatever optimization techniques we apply, that will be done on the intermediate code, and the final intermediate code will be again mapped to the machine language. And that is a practice being applied. So these are all the requirements for intermediate code. Even without an intermediate code, compiler can work. But sensing the need for multiple requirements, designers of compilers went for such a phase. And that answer we have Now we know why there has to be an intermediate.